Welcome everyone to Algebra 1A Live. This is a week 7 video getting into solving problems using algebraic equations. We're going to be looking at week 7. Make sure you go through our online textbook, take notes, watch this video, do some practice problems so you're starting to understand all the topics for this week, and then show me what you learned in the weekly assignments. If you have any questions, again, come to my online classroom, send me a message, we can set some appointments. Make sure you're getting the help that you need. For week 7, what are we going to learn? We're going to learn how to represent and solve word problems using proportions. We're going to use indirect measurements and equations to solve scale problems. We're going to use the percent equation to represent and solve word problems. And we're going to represent and solve problems involving percent change. So we're taking common types of scenarios, proportions, scale, percents, and learn how to represent them with the right equation to solve it out. So in any situation that you're trying to use algebra to represent and solve a situation, what's your first step? Your first step is to define what you want your variable to be. That's a big key. If you're using algebra, which means basically you're using variables to represent unknowns, you need to be very clear about what it is. What does x represent in this problem? If you don't know, then you're going to have a hard time using algebra to solve it. So that's a lot of what we're going to do. We're going to start off by defining what we want our variable to be and solving it out. So here's the rest of the steps. We're going to go through this process slowly, but if you're trying to do a word problem, if you're trying to use algebra as a problem-solving tool, define what you want your variable to be. In the problem, look for any mathematical relationships. Should some things add together? Do some things multiply together? Are some things a total of sum of stuff? You're looking for things that make sense mathematically. You can also represent the problem with a picture or a chart. This helps me organize what I'm seeing or help me make sense of what the problem is the context is. And then once you make sense of it, when you're starting to put together these relationships, you've got a sense of what's going on with the picture of a chart, then you can actually put together an equation that makes sense. Once you have the equation, we've been working the last couple weeks on how to solve it. That's easy, right? Just rearrange it, solve for what your variable is, and then your very last step, see if your solution makes sense. You get some number for your variable. Does it actually make sense with what the question is asking you to find? There we go. These are problem-solving strategies, kind of a 6-step process. And again, the more you do this, the more naturally these processes will become. All right, let's start off with proportion problems. A proportion is when one ratio is set equal to another ratio. And again, a ratio is just a fraction. We can write it as a fraction. And so typically a proportion problem, you can write it like this. There's one ratio equal to another ratio. Oftentimes we know 3 of the things and we're trying to solve for the unknown 4th thing. So let's look at some proportion problems. A small fast food chain operates 60 stores and makes $1.2 million profit every year. How much profit would the chain make if it operated 250 stores? Okay, let's think about putting this into a proportion problem. So I do know that 60 stores, I can write a ratio, right? For 60 stores, we're told that they make 1.2 million profit. Notice that I'm writing out my units, I'm writing out what these numbers mean. And we're assuming this is proportional because it's saying, what if I had 250 stores? Assuming that it grows proportionally, how much profit would I get from 250 stores? There's my problem right there, my proportion problem. We solve it the number of different ways, but algebraically, there would be my x for my unknown, and x represents profit for 250 stores. Okay, to solve it, I need to get x by itself. I need to rearrange this thing. I can rewrite it with x on top. So I can say, well, x over 250 then is the same as 1.2 over 60. And then to get x by itself, right now it's being divided by 250, so I'm going to multiply both sides by 250. It's the opposite of dividing. There we go. So x equals whatever all this calculates out to be. So let's pull out your calculator. And we're going to do 250 times 1.2 divided by 60. And we get x equals 5. All right. Now really that's not the answer though, because the answer is how much profit if they make in the stores, and the profit is given in millions of dollars. So I need to answer with a good answer. I say they profit would be $5 million. You got to fully answer the question that the problem is asking you. There we go. That's a good proportion problem for us. Let's take a look at another one. A cross-country train travels at a steady speed. It covers 15 miles in 20 minutes. How far will it travel in 7 hours, assuming it continues at the same speed? All right, so a lot of you may be tempted to jump to this. Okay, so 15 miles in 20 minutes, and I want to know when that's equal to 7 hours. And my unknown x, we're going to define x as the distance in 7 hours. Distance in miles in 7 hours. Distance traveled in 7 hours. Okay, what's the problem with setting it up like this though? The problem is I'm not being consistent with my units, right? This is miles to minutes. But later on, I'm comparing that to hours. If I want to set up a ratio problem, I need to make sure my units are consistent. So I either need to change 7 hours into minutes, or I need to change 20 minutes into hours. So I think I'm going to change 20 minutes into hours. 20 minutes out of 60 minutes, I'm going to rewrite this as 15 miles over 1/3 of an hour. How does that compare with our unknown miles for 7 hours? Okay, again, a lot of different ways you could solve this out. Use some algebra here and multiply both sides by 7. Because 7 divided by 7 will leave x, and x equals 7 divided by 15, or 7 times 15 divided by 1/3, and we get 315. So 315. So how far do they travel? Travel 315 miles in 7 hours. All right, there's a couple good proportion problems for you. Scale problems. Scale problems involving more ratios, but comparing ratios of size. And we're using scale involved in maps, blueprints, and other model representations. So let's do some scale problems with proportions here. Oscar is trying to make a scale drawing of the Titanic, which he knows was 883 feet long. He would like his drawing to be at a 1 to 500 scale. How many inches long does this sheet of paper need to be? Okay. So let's figure out how to represent this proportion. So we have a scale factor of 1 to 500, right? Which means that for every 500 feet, his drawing would be 1 foot, right? that would be a 1 to 500 scale. We're basically taking the real thing and shrinking it down by 500. Okay, so we do know the Titanic was 883 feet long, and we're wanting to shrink that down by a scale of 1 to 500, so we need to find, well, what is a scale? So x is going to represent the model length. All right, let's solve it out. I'm going to multiply both sides by 883 to divide that out, leaving x by itself on the right side. On the left side, I just need to do 883 divided by 500. What do we get? 883 divided by 500, and we get 1.766 equals x. Now again, we solved it algebraically, but we got to answer this problem here. I'm supposed to tell how many inches long does this sheet of paper need to be. What we found was actually the feet. Remember being consistent with our units? So 1.766 feet to 883 feet is a 1 to 500 ratio. But now I need to multiply it by 12 to convert it into inches, right? 12 inches per foot. So I'm going to take 1.766 multiplied by 12, and we get 21.192 equals x. How many inches long? Approximately 21 point, I'm going to round it to the nearest tenth, 2 inches long. All right, there's a scale model of the Titanic. That's his basis of how he's going to draw that thing out. All right, percent problems. We love percent problems. Probably the most useful math that you can learn in school is how to deal and understand percents, including finance, shopping, all sorts of applications of percent. So here we go. A percent problem. All percent problems you can use an algebraic equation to solve. So we have a percent rate, which we got to use the decimal, multiplied by some total amount gives us the part, right? So if we want 20% of 280, we would take 0.20, that's 20 out of 100, or 20 divided by 100, times 280. That's going to give us a part. So 20% of 280, 0.2 times 280, and we get 56. Now you can compare this as a ratio too if you really love to use ratios. Basically we just said 20%, 20 out of 100, is equal to what out of 280. So we just solved this proportion problem and found out that it has to be 56. And you can solve that out yourself if you want to check it. But there you go. You can use an algebraic equation to solve percent problems. All right, you travel to Washington and you want to purchase a new kayak and it's listed for $650. In Washington, however, you have to pay a 9% sales tax. How much total will you end up paying for the kayak, including tax? All right, so this is an increased one. So original amount is $650. And with the percent, we need to figure out what 9% is and then add it to it. So let's multiply it by 0.09. That's going to be 9%. And 9% of $650 is, whoops, hold on, let me do that again. 0.09 times 650 is $58.50. So that's a good amount, right? That's a bummer of a tax to pay. 9% is close to 10% of it, right? So there we go. So how much total? That's the tax. The total is going to be $650 for the kayak, plus you pay a tax And that's going to be a total of $708.50. Pay a total of $708.50. There we go. We just answered that question right there. One more percent problem. In 1995, New York had 18,136,000 residents. There were 827,025 reported crimes. Of those crimes, 152,683 were violent crimes. But 10 years later, by 2005, the population had increased a little bit, and that was 19,254,630. And there were 85,839 violent crimes. So it went down by a considerable amount, right? Out of a total of 491,829 reported crimes. That went down by a lot. Calculate the percentage change now, and we're using these data numbers. We're going to calculate the change. So how much did the population change? All right, let's start with that, population. So we went from 18,136,000 to 19,254,630. So we definitely increased, right? So if we want to calculate the increase, we can set it up as an equation, right? Let's do our percent. We're going to solve for unknown percent. So my percent times 18,136,000. We increased by an amount, and it increased after the percentage change, it increased up to 19,254,630. Now to solve for this unknown value p, I'm going to divide, right? Divide both sides by 18,136,000. And we'll get our percentage change. Okay, pulling out my calculator. 19,254,630 divided by 18,136,000. And we get P equals 1.06. I'm going to round it to 2. It goes on 6.1, 6.8, and it goes on and on. But I'm going to round it to the nearest 2. What that means is we increased by this little amount right here. So the population increased by 0.062, which if I multiply by 100 is 6.2%. All right, that's the population change. It increased. Now let's look at the number of crimes. I'm going to do the number of crimes, and I'll let you guys do the violent crimes on your own. Actually, I'll do the violent crimes. Give a little more space here. So violent crimes, what did we do? What did we start with? So we had 85,839 violent crimes in 95. And then 10 years later, that was down to, whoops, got the wrong number. So this was in 2005. But before that, previously, so I got your numbers right. Previously, it was 152,683. That's in 1995. So we decreased, right? It went from 152,000 to 10 years later, almost half that, 85,000. So we want to find what percentage decreased. Again, we're going to do the same sort of equation, right? My percentage I'm trying to find, we started with 152,683, and after my percentage changed, the result was we went down to 85,000. 839. When I solve that, I'm going to divide both sides. 152,683 divided by 152,683. And if I do the math there, we get 85839 divided by 152,683. And we get P equals 0.5 rounded to 5/6. Okay, what does that mean? Well, it means 56% of the original amount is what we had left. So 56% of the original crime rate is what it is right now. But we want to know how much did it change, right? If it went 100% down to 56%, that means it actually decreased. We need to do 100 minus the 56 that's left to find out how much it was decreased, which is going to be 44. So it started at 100%, lost 44%, so decreased 44%. And what's left is the 56% that I just calculated. There's a couple examples of finding percent change, setting up an algebraic equation, working with some statistics, some numbers to find percent change. All right, there we go. Did a wide variety of problems involving proportions, scale problems, word problems, percent change problems, and we were able to set up algebraic equations to solve these things out. Hopefully this is helpful. Again, for week 7, make sure you're also reviewing over weeks 5 and 6 and understanding what to do in those problems.